here we're asked to find the integral from 0 to infinity. So the interval for this integration is not defined. It's not definite, so we've got from 0 to infinity of the function e to the minus x with respect to x equals, what we can say is it'll be the integral between 0 and p is going to approach infinity, so it'll be the limit as p approaches infinity of e to the minus x dx. Okay, so we'll evaluate the integral and with a value of p, and then we're going to use our property of limits to have p approaches infinity to find out if this actually exists or if it diverges. So the process is to continue writing limits until we actually substitute p for infinity into the integration. So we'll write limit p approaches infinity of, now the integral of e to the minus x is e to the minus x over negative 1, and that'll be between the values of 0 and p. So just, you can check, find the derivative of e to the minus x, you get negative 1 e to the minus x, the negative 1s will cancel, so you get e to the minus x. So finding the derivative of that, you should get back to that. So that's correct. So we've got between 0 and p equals the limit as p approaches infinity. I'm not going to substitute in yet, but I'll put these values of p in here. We won't worry about infinity yet, so we'll just put p in there. So we've got e to the negative p over negative 1 minus e to the negative 0 over negative 1. Limit p approaches infinity. Now that is simply just negative e to the minus p, and e to the power of 0 is 1. That'll be minus negative 1, so that'll be plus 1. So e to the 0 is 1, and that negative will make that into a positive, so you've got positive 1 there. So it's just 1 minus e to the minus p. So that will be 1 minus, now e to the minus p is 1 over e to the positive p, but we'll make p equal to infinity. So e to the minus p, 1 over e to the p, and then we'll put in p equals infinity. Now e to the infinity is going to be a very large number. 1 over a very large number is 0, so it is equal to 1 minus 0, which is just equal to 1. So therefore we can say that the integral converges, because we've got a value, to 1. Okay, very similar looking integral, but it's done in the same way. We've got the limit. Now we have used p up above, so I'm going to use q approaches negative infinity, and that'll be the integral between q and 0 of e to the minus x dx equals the limit as q approaches negative infinity, e to the minus x is equal to e to the minus x over negative 1. That is going to be between q and 0, is equal to the limit as q approaches negative infinity. We keep writing that down until we actually make a substitution in here. Now we can do some evaluation here. So e to the power of 0 is 1 over negative 1, so that'll be equal to negative 1. Putting 0 in there, minus, and now it'll be minus, this negative 1 will be minus, it'll be plus e to the negative q. Okay, so that'll be the limit approaches negative infinity of e to the negative q is 1 over e to the q, so that'll be negative 1 plus 1 over e to the q equals, now we can do our substitution in, negative 1 plus 1 over e to the minus infinity. Now 1 over e to the minus infinity will be actually equal to, brings it back upstairs again, so e to the infinity. E to the infinity is a large number, and so therefore that's going to be actually equal to, because that's very, very large, approaching infinity, this is not going to have any effect on it, so it's going to approach infinity. Therefore we can say that the integral diverges.